let's do a quick concept check here. Let's assume that you have a distribution, a sample, and the mean of that sample is 50, and the standard deviation for your sample is 2. What would the relationship look like between x and z? Okay, so again, x bar is 50, standard deviation is 2. Well, everybody by now should be able to tell me what 50 becomes. So 50 in the raw score distribution, the mean becomes what on z? Tick, tick. 50 becomes 0, right? The mean of any raw score distribution always becomes 0 on z. What about 52, 54, 56? Well, you have to go back up here, right? Standard deviation is 2. That means that when you jump 1 unit on z, you actually have jumped 2 raw scores. So this is a 52. These two line up. What about if you go from 0 to 2? Well, 0 to 2 means you've jumped 2 here, 2 raw scores, and another 2 raw scores here for a total of 4 raw scores. So the 50 plus 4 brings you to 54. All right, so these line up. And if you jump another another z-score unit here, you've jumped another 2 raw scores here. That brings you up to 56. Okay, so same thing going backwards. Every time you jump 1 unit on z, you're jumping 2 on the raw score distribution. But now we have to subtract. So it goes 50, 48, 46, 44. You see it's going down by 2 each time. Now, think about this. If we have 23 people who got 52 in our data set. Okay, so we have 52 23 times. 52, 52, 52, 23 of them. How many z-scores will we have? Well, if there's 23 52s, how many 1s will we have? How many of these z equal 1? We'll also have 23, right? What about if we have 148s? 100 people got this score. So when we convert each and every one to z, we're going to get -1 each time. So if we have 100 of these, we're going to have 100 of these. This is why the shape of your raw score distribution and its corresponding sample of z-scores will always look the same. They will line up perfectly. Click a little fast. Will line up perfectly, okay? Pinky promise. If your raw score distribution looks like some freaky Mickey Mouse distribution, then the corresponding z-score distribution will look like some freaky Mickey Mouse distribution. They're going to look identical. Only the x-axis changes. Because remember, if you're looking at the raw score distribution, you're plotting raw scores. And if you're looking at the z-score distribution, you're plotting z-scores. Otherwise, they're identical.